discuss the formulas. So because that this is static, remember we said static is the maximum that one needed. Né? So now we're going to say that F max it's equals to U, because it's static, it's US times the normal force.
Yeah.
Nice. But now remember, this is just on a horizontal surface, and the force is parallel to the surface. Can you see that?
Yes.
Which will make the normal force Fn to be just mg, okay?
Yes.
But now remember, the coefficient of friction was given as 0.3. So we're just going to say this is 0.3. We multiply this by what? The mass and the gravitational force. So the mass is given as 50 on the object. So the mass is given as 50, and this is 9.8. When you punch that on the calculator, what do you get?
147.
147. And now you'll be saying, why is showing me this easy example? Why am I showing you this? So that we can answer the next question. Because listen to this question. It says that a force of 20 Newton to the right is applied. Okay. Yes, we can see that a force of 20 Newton is applied on the object. So it's applied. So they say, what is the force of friction? What is the force of friction while the force is applied?
Oh, okay.
So now, the reason we did the first one is that I need you to know that we have the 20 newtons to the right that is applied, right? So my answer to this, I'm going to explain. My answer to this, a force of 20 newton is applied to the right. What will be friction? Frictional force, the answer to this is 20 newtons to the left. Ask me why. So we are saying that the answer to this will be 20 newtons left. I'm going to explain why I'm saying that. Remember, as the applied force, can you see this applied force? This applied force is 20 newtons, right?
Yes, sir.
The applied force is less than the maximum. The applied force is less than the maximum force of static friction. So the friction will apply the same force in the opposite direction to stop the crate from moving. So this tells us that in order for the crate to move, we need an applied force that is greater than 147. Even if we change the force and put the force as 100, the frictional force will also be 100. Why? Because in order for the crate to move, we need a force that is larger than what? That is larger than the maximum force.
So honestly, you lost me. I don't know what's happening now.
Oh, okay. Let's explain this again, okay?
Okay.
First thing first, we know that the coefficient of static friction between the crate and the surface is 0.3.
Yes.
So now we calculated the maximum force of static friction. Remember, we need to go back and explain what is the maximum force of static friction is. I'm sorry. Is the how can we say this? We say that the static friction is the frictional force on the stationary object that opposes the motion of the object. So when the parallel component and the applied force increases, the magnitude of the force and the static friction will also increase. So what I'm saying is that in order for us to move the crate, we need a force that is larger than 147. Can you agree with me on that?
Yes.
Okay. So now the question is asking, what is the force of friction while we apply the 20 newtons? So now this is my crate. We applied a force of 20 newtons. You understand?
Yes.
But the force is not moving. Why? Because the crate is not moving. Why? Because we need a force that is greater than 147.
Okay.
So
Okay.
if the force is not moving, this will make the frictional force to be also 20 newtons, because it will apply the same force as the applied force to prevent the crate from moving.
Yes. Yes. Now I understand.
Is that making sense now?
Mm.
So the answer will be 20 newtons. Why? Because the applied force is less than 147. So in order for the crate to move, we need the applied force that is greater than 147 newtons.
Okay.
Isn't it?
Yeah, but I think I need to go over it again, like by myself.
Okay, maybe I can also, I'm not sure. Do you want me to write it down for you?
The thing is, I don't understand why. I understand that the force has to be more than 147 in order to move, ne? But the question, like, I think it's the way the question is asked. I don't know.
Oh, okay. If I write this, you'll understand. Friction cannot be greater than the applied force.
Okay.
This frictional force, it cannot be greater than the applied force. That's what we know again. So now we have the applied force that is applied to the right, okay?
Yes, the 20.
Exactly. So this applied force, it's less than 147. You understand?
Yes.
And in order for the crate to move, we need a force that is more than 147.
Oh.
Since the applied force is less than 147, the friction will be equals to the applied force, but in an opposite direction.
Okay, so basically what we calculated then on top by the 147 is how much force will be needed to move the crate.
Exactly.
Oh.
That's what we call the maximum
friction force.
Exactly, the maximum friction.
Okay, now I understand.
Yes, the maximum friction needed is 147 and above. So now, remember, the friction cannot be greater than the applied force. So now, the friction is 147, which is greater than this applied force. The crate won't move, which will make the frictional force to be equal to that one.
Oh, okay.
Is that making sense?
Yes, so it makes very much sense now.
You were scaring me when you say you don't get it.
I was scaring myself.
But it's fine. I think if you can get the notes, I'll just try to write the note.
I think it's not understanding what we are calculating, because the minute I found out that actually when we're calculating the maximum frictional force, we're calculating how much force will be needed to move the crate. So I think as we go, so I can explain, okay, so the reasons why we calculate this, it's because of that.
100%. So now I'm happy that you get it. And now what I need us to do, now that we did the frictional force, we're just gonna do one example on frictional force, then we'll move to one example of an inclined, so that on our next lesson we can start the most interesting topic, Newton's second law of motion. Remember, everything that we did, we haven't touched Newton's law.
Okay, so
We haven't touched Newton's first law, we haven't talked about Newton's second law. So what they do is that in